Now my dear students, today we are starting this chapter, crash course. In crash course chapter number 4, hydrogen, S block elements and P block elements. My dear students, we are cover these 3 chapters because these are very small chapters and you can see 2 or 3 questions are come in NEET exam. So my dear students, we can cover these 3 chapters in and cover the all questions and all concept, and I give you some concepts, some tricks and theory. Now my dear students, we can go to the question number 1. Question number 1, one would expect proton to have very large. Proton is a very large. What is the concept of this question, my dear students? Concept of this question. H plus ions, 1 electron and 1 proton is present. 1 electron and 1 proton present in this hydrogen atom. This is the hydrogen atom in which 1 electron and 1 proton is present. When this electron is removed from this and it is converted to H plus ions, and in this H plus ions you get only 1 proton in H plus ions, and it is called this proton in which only 1 proton is present. So my dear students, one would expect proton to have very large, but this proton is very large. Why? About its radius? No, not at all. What is the radius, my dear students? Here, radius is the distance between the nucleus and outermost electron is called radius. So this radius is a very small. Now we can see here charge. Due to this charge, it is not heavy because only 1 charge is present. Due to ionization potential, my dear students, ionization potential, only 1 electron is there, so less amount of energy is required from this hydrogen to remove this electron. So ionization potential is not very high. So my dear students, here you can see the answer C, question number 1 for C, because this H plus ions, when present, H plus ions is not present in a free state. H plus ions is not present in a free state in water. My dear students, in H plus ions reacts with water to form hydronium ion. It is always present in the form of hydronium ion. So we can see its very large structure due to see this hydronium ion. So structure of hydronium ion is very large. So you can see the structure. So my dear students, question number 1, your answer is C, hydration energy. Now we can go to the question number 2. The ionization of hydrogen atom would give rise to. My dear students, when you can, this hydrogen atom, this electron is removed and 1 electron is removed and it is converted to H plus ions. And what is the ionization? Ionization of hydrogen is called removal of an electron. It is called ionization. So you can get this is called proton. So my dear students, you can see this is called proton. And what is the hydronium ion? When this proton reacts with water to form this as 3 plus ions, it is called hydronium ion. So my dear students, it is called hydronium ion and it is called proton. So in this way, you can see here, this is the hydronium ion and this is the proton. So the ionization of hydrogen atom would give rise to the proton. Now my dear students, we can see the question number 3. Which one of the following pairs of substances on reaction will not evolve hydrogen gas? My dear students, when we see the electrochemical series, in this electrochemical series, those metals present above in the hydrogen, this is the electrochemical series, and in this electrochemical series you can see here this is the hydrogen atom, and when this hydrogen atom present here and these elements are present above this hydrogen. So my dear students, these elements react with acid to evolve hydrogen, but this copper is present below the hydrogen. So my dear students, this copper is not reacts with hydrogen to evolve HCl. So you can go the answer A. Question number 3, you can get the answer A, because iron is present here above the hydrogen. So it reacts with steam to evolve hydrogen. Iron reacts with H2SO4 to evolve hydrogen, as well as you can see here ethyl alcohol and sodium. My dear students, ethyl alcohol C2H5OH and sodium metal Na. When this ethyl alcohol reacts with sodium metal, 2 mole of ethyl alcohol reacts with 2 mole of sodium metal to form, my dear students, twice CH5ONa sodium ethoxide, and H2 molecules evolved. So hydrogen is also evolved when this ethyl alcohol reacts with sodium metal. So my dear students, you can go the question number 3rd, option A. Now we can see here question number 4th, water gas is produced by. Here my dear students, basic reaction, I give you theory and reaction. In this theory and reactions, you can see here all questions are come from the reactions. So my dear students, you must be see the reactions and you must be remember. Here water gas is produced by, answer is A, my dear students, because here water gas and passing steam through a red hot coke. When, my dear students, this is coke and this coke is a red hot, means this coke is heating at high temperature, so it is completely burned but not converted into CO2. It is called red hot coke. And when this red hot coke, water is not from the liquid, water is in the form of steam are heated with red hot coke. My dear students, this CO carbon monoxide and H2, here this carbon reacts with oxygen to CO gas, and here this hydrogen gas are formed, and my dear students, these gases are called water gas. Why these gases are called water gas, my dear students? Because these gases are formed by steam, so these gases are called water gas. So my dear students, you can go the question number 4th, option A. This question is also asked in 992 NEET exam. Now we can go to the question number 5th. Which of the following metals evolve hydrogen on reaction with cold dilute HNO3? My dear students, we can see the reaction of this question. This question is asked in 1989. Here my dear students, it is a exception reaction when this magnesium reacts with dilute and cold HNO3. This dilute and cold HNO3, magnesium reacts cold. My dear students, to form magnesium nitrate, MgNO3, magnesium nitrate is formed, plus this hydrogen is evolved. So my dear students, this magnesium is a highly electropositive metal, reacts with dilute and cold HNO3 to form magnesium nitrate, and hydrogen is evolved. It is a special reaction for magnesium. Only magnesium give this reaction, hydrogen, and another compounds give NO2 and nitrate and NO2 or N2. So my dear students, it is a important reactions and it is only given by this magnesium. So this reaction is come in the form of question in NEET exams 1989. Now we can here see the question number 6. Which of the following statements about hydrogen is incorrect? Here you can see the question number 6. Question number 6 wants the incorrect statement here, and incorrect statement number 1, A, hydronium ion exists freely in solution. Hydronium ion exists free in solution. Yes, it is a correct. Why? Because H plus ion is not present in free, but hydronium ion is present, exists or present freely in solution. Number B, dinitrogen does not act as a reducing agent. No, not at all. It is a wrong statement, my dear friends. So answer is this, dinitrogen always act as a reducing agent. Now we can go to the C option. Hydrogen has 3 isotopes, of which tritium is most common. No, not at all, my dear friends. Tritium is not most common, so B is also a correct answer. Here hydrogen never act as cationic in ionic salts. No, hydrogen act as a cations in ionic salt. So your answer is B and C. These are incorrect statement. And this question is also asked in NEET 2016. Because dihydrogen is act as a reducing agent, because this, when we can see the reaction, this dihydrogen reacts with this ZNO or CuO, it is reduced to it form H2O plus Cu. So it's act as a reducing agent. Here you can see +2 oxidation state present and here 0. So here reduction is occur and hydrogen oxidation state is 0 and here +1. So here oxidation is occur. In this way you can see here this hydrogen is act as a reducing agent. So my dear students, you can see the option B as well as C. This protium and deuterium. Tritium is most common. It is a wrong statement. Tritium is present in a less amount. Now we can go to the question number 7. Which of the following is electron deficient? My dear students, 13 group elements. Concept is that 13 group element boron, aluminum, gallium, indium and thulium. Here when you can see the outermost electronic configuration NS2 and NP1 is present here. So when these elements form the trihalides, for example BCl3 or BS3, because my dear students trihalides is formed because unpaired electrons are 3, 2 and 1, 3. If these electrons go to in p orbitals, so you can get the 2s2, 2px1 and 2py1. In this way you can get the 3 unpaired electrons, and when these 3 unpaired electrons are present, so my dear students you can see here when these 3 unpaired electrons are present in the outermost shell, so it forms a BCl3 or BS3. This type of compounds are formed. When this type of compounds are formed, my dear students, when you can see the boron, here 1 electron, 2 and 3 electron per electron, and here chlorine form the bonds. So this boron atom gets 6 electrons in outermost shell, but you know very well here octet is not complete. So this boron bonds the 2 electrons from any source. So this BCl3 is act as a Lewis acid, and these 13 group elements are act as a Lewis acid. Here my dear students, here boron is present here, BS3 whole twice, so it's electron deficient. BS3 is electron deficient, so BS3 is form a here banana bond or 3 center electron pair bond, my dear students. Here in this type of bond is formed. Here you can see the electron pair boron and this hydrogen. Here you can see the electron pair of hydrogen and boron. Now we can see here this electron pair is participated boron and hydrogen here because bond is formed, but this pair also participated by this boron also, my dear students. Why? Because p orbital of this are empty, so empty orbitals are overlap with this hybridized orbital of boron and hydrogen atom. So in this way here this type of bonds are present. Here this boron atom also formed the here and also sharing the electrons of this B and H group. So my dear students, here these are sharing the electrons, but boron have empty p orbitals here and here. Both boron have empty p orbitals, so empty p orbitals are sharing with this. So this B2S6 molecules, or you can say that BS3 whole twice molecule is electron deficient. So my dear students, you can go to the question number 7. Option is A. When you can see the question number 8, the method used to remove temporary hardness of water. Here my dear students, this question is asked in NEET 2019. What is the concept? My dear students, temporary hardness is due to the presence of calcium bicarbonate and magnesium bicarbonate. These salts are present in water. So my dear students, temporary hardness is produced. Now we can see this is removed by, my dear students, this temporary hardness is removed by the Clark method. When you can use this Clark method, this temporary hardness is removed. Because other hardness, synthetic resin, Calgon method and ion exchange method, by this method permanent hardness is removed. pH, Calgon, pH, permanent hardness, and permanent hardness is removed by these methods. In Clark method, this calcium bicarbonate, magnesium bicarbonate are converted into carbonates. So, we can remove it. Now, my dear students, we can go to the question number 9th. This question is also asked in NEET 2019, and what is the reaction and what is the formula of this question. Here, my dear students, we can see the concept. The number of hydrogen bonded water molecules associated with CuSO4 dot 5H2. Here, my dear students, you can see here number of hydrogen bond water molecules. Here, when this CuSO4 5H2O, you can see 4 this copper is present in a +2 form. So, here when you see the structure formula, this water molecules, here lone pair electrons of oxygen gives lone pair electrons to form coordinate bond. Here this is the coordinate bond is formed by the lone pair electrons of oxygen atom. So, my dear students, you can see here 4 water molecules are from the coordinate bond. Now, we can here sulfate molecules, these sulfate molecules SO4, this SO4 is present, and this SO4 molecules, and here 1 molecules of water is remaining. So, my dear students, you can see here 1 molecule of this molecule, and here this. Here, my dear students, this is the minus charge present, and here this is the minus charge present. So, this minus charges are also attached by this hydrogen. So, you can see here minus charges are present here. So, my dear students, you can see here this is the hydrogen bond present with this molecule, and here +2 charge is present. So, here ionic bond is present between this copper and this O minus. So, in this molecule you can see coordinate bond, number 1 coordinate bond, number 2, my dear students, ionic bond. Here this is the ionic bond, and S and O, here this is the covalent bond, and number 4th one, this is the hydrogen bond. These are the present in this CuSO4 5H2 molecule. Now, question is that how many number of hydrogen bonded water molecules present. So, this is a 1, only 1 water molecule is present or attached with this whole molecule. So, you go to the answer B, and only 1 water molecule, hydrogen bonded water molecules. Hydrogen bonded water molecules 1, other water molecules are present by the coordinate bond, here coordinate bond. So, by this structure, my dear students, you can verify this, and this is the structure. And how many bonds are present? Coordinate bond, ionic bond, covalent, hydrogen bonds are present. Now, my dear students, we can see the question number 10. Which of the following groups of ions makes the water hard? My dear students, here magnesium chloride is from the water hard, because here NaCl or NHCO3 sodium bicarbonate, this is the sodium bicarbonate is a, you can baking soda you can use in the food. So, it is not making the water hard, but this magnesium chloride MgCl2 or MgSO4, or you can see MgSO4 magnesium sulfate, or you can see CaCl2, or you can say CSO4. These 4 ions when present in the water, then water becomes hard. This present in the water, then water become hard. So, my dear students, you can see the hardness of water. So, you can go the question number 10th, answer is B. This is the theory which is given in your NCERT books. Now, we can go to the question number 11. At its melting point, ice is lighter than water because my dear students, answer is B. Here ice crystal have a hollow hexagonal arrangement of water molecules, and in hexagonal arrangement, that is why space is there, vacancy is there, these are vacant, hexagonal. So, volume is greater and volume is greater than density is low, because you can see the density is equal to mass upon volume. So, my dear students, when volume is higher then density is low. So, ice floats on the water. So, my dear students, you can use this formula and get the answer. D is equal to m upon B. Now, 11th question number B is the correct answer. Now, we can go to the question number 12, my dear students. In question number 12, match of the following and identify the correct option. This question is also asked in NEET 2020. Here, my dear students, we can see the temporary hardness of water. Now, I can teach you temporary, I can teach you in this chapter, and these questions are also present. My dear students, temporary hardness of water is due to this magnesium calcium bicarbonate. Now, I can also teach you B2S6 is the electron deficient hydride. So, my dear students, you can go to the B for 1 and C for 2, B for 1 and C for 2, B for 1 and C for 2. So, my dear students, you can go to the option A. Question number 12, answer is A. And that A third means this is called synthesis gas, and hydrogen peroxide is a non-planar structure. Here H2O2 is a, you can get the book structure of in H2O2, book structure, open book structure. You can get the open book structure. Now, we can see here question number 13. The structure of H2O2 is, the structure of H2O2 is spherical, non-planar, planar or linear. Now, it is a open book structure, so it is a non-planar. In this type you can see the structure, here a hydrogen and hydrogen, so it is a non-planar structure. Now, my dear students, we can see here question number 14. The volume strength of 1.9 normal H2O2 solution is, this question is asked in 1996 as well as 1997. My dear students, volume strength, I give you concept and formula, how can calculate it. My dear students, normality, N is equal to 1.5 here given in the numerical. So, what is the strength? We can get the strength that equal to normality into equivalent weight. Into equivalent weight. Here, my dear students, what is the normality? Normality is 1.5, and what is the equivalent weight of H2O2? That is 17. So, strength you can get the strength, that is 25.5. Now, we can see here reaction, twice H2O2, 2 gives twice H2O plus O2, 1 mole of O2. So, you can get 22.4 liter as a Avogadro number. Here 2 into H2O2, molecular weight of H2O2 is, that is 34. So, 68 gram of H2O2, you get the 22.4 liter. So, my dear students, here we can take the 25.5, here we can see 68 gram of H2O2 produces 22.4 liter of oxygen at NTP. Now, we can see here 25.5 gram of H2 produces 22.4 into 25.5 upon 68. Then my dear students, here you can replace this point and place 0 0, multiply by both quantity and divided by 68. Then my dear students, you can get the here 8.4 answer, that is 8.4 liter of oxygen produced. So, your answer is B, 8.4 liter. This is the question number 14. In this question, my dear students, you get the answer B. Now, we can go to the question number 15. The OOH bond angle in H2O2 is, here my dear students, you can see the bond angle directly, that is 97 degree bond angle present in H2O2 is open book structure, and in this open structure, that is 97 degree is the bond angle. Now, we can go to the question number 16. Here question number 16, ionic mobility of which of the following alkali metal ion is lowest when aqueous solution of their salts are put under an electric field? My dear students, what is the concept of this question? Most hydrated ions have least ionic mobility. So, my dear students, you can see which ion is the most hydrated, that is example lithium Li plus, because its size is small size is present. So, my dear students, here size is small, so water molecules is adsorbed by around this lithium ions. So, my dear students, it is a most hydrated, and it is most hydrated. So, here aqueous solutions of their salts. So, ionic mobility is least. So, my dear students, you can go to the question number 16. Answer is C, lithium. This question is also asked in NEET 2017. Now, we can go to the question number 17. Which one of the alkali metals form only the normal oxide M2O on heating in air? My dear students, here lithium is a representative elements in this group, because in this group lithium, sodium, potassium and rubidium are present. So, my dear students, here lithium is a first element of this group, and when lithium is the first element of this group, so my dear students, here you can see this lithium, when this lithium is heated in air plus oxygen, this is formed lithium monoxide. It is called lithium monoxide. Why, my dear students? Na, when this Na is heated with air, you can get its form Na2O2, sodium peroxide. For some amount of NaO2 is also there, small amount, and it is written in NCERT book here, small amount, and it is called sodium superoxide, but it is a small amount, sodium superoxide. And other, this potassium and rubidium, my dear students, potassium and rubidium, when reacts with oxygen to form KO2 as well as RbO2. So, it is called potassium superoxide or rubidium superoxide. So, my dear students, you can see here only lithium is from the Li2O or lithium monoxide, and these are the reactions. Question number 17, answer is C. Now, we can go to the question number 18. This is easy of adsorption of the hydrated alkali metal ions on an ion exchange resins, follow the order. Here, my dear students, you can see here hydrated alkali metals. Here we can see the smallest, the ion are more hydrated. Here lithium, sodium, potassium, rubidium, size is increases. So, these are the least hydrated. So, my dear students, answer is B. Question number 18, Your answer is B. Now we can go to the question number 19. The sequence of ionic mobility in aqueous solution is. Here my dear students, ionic mobility when hydration is maximum means ionic mobility is less. But in aqueous solution the sequence, if you get the sequence, except this lithium has most hyded ionic. After this lithium, sodium, potassium, rubidium, cesium, hydration is less, not hydrated more. So my dear students, here ionic mobility sequence is, this one is greater the size, cesium plus, and here rubidium, then potassium, then sodium. So you can go the answer D. 19 answer is D. Now we can go to the question number 20. Here when a substance A reacts with water, it produces a combustible gas B and a solution of substance C in water. When another substance D reacts with the solution of C, it also produces the same gas B on warming, but D can produce gas B on reaction with dilute sulfuric acid. Now my dear students, substance A, in case we can see the substance A is sodium. A is sodium. When reacts with water to form a NaOH, and hydrogen is liberated, and this hydrogen is a combustible gas B. And a solution of substance C in water, this is a substance C in solution in water. When another substance D reacts with this solution C, it also produces the same gas. When my dear students, here you can see the A, sodium, B, hydrogen, C, NaOH. When another substance, for example zinc, it is a D substance, reacts with C means NaOH to form my dear students Na2 ZnO2, sodium zincate, and hydrogen is liberated. Sodium zincate and hydrogen is liberated H2. So these are D and hydrogen, same hydrogen B is liberated. With dilute sulfuric acid at room temperature, substance A imparts a deep golden yellow color. Yes, sodium gives deep yellow golden color. This deep yellow golden color is given by this compound and it is a zinc. So my dear students, this sodium is give us golden yellow color to a smokeless flame of Bunsen burner. Then A, B, C and D are. You can get the answer C. This is A, B, C, D and these are the reactions. If you know the reactions, then you can easily solve this question. This question is also asked in 1998 NEET exam. Now we can here see the question number 21. Which one of the following properties of alkali metals increases in magnitude as the atomic number rises? My dear students, when you can see the alkali metals is a lithium, sodium, potassium, rubidium and cesium. These are the alkali metal or first A group elements. And here you can see the properties. Electronegativity decreases because it is a periodic properties. First ionization energy, it is a decreases. So my dear students, these properties are decreases. And third one, my dear students, melting point is also decreases. So only one property is ionic radius. It is increases when we move top to bottom. So these are the properties which are given to you. Now we can go to the question number 22. In the case of alkali metals, the covalent character decreases in the order. My dear students, you can see here covalent character. What is the concept? Larger the size of an ion plus smaller the size of cation. That bond is more covalent in nature, in ionic compound. So my dear students, you can see here this is the concept. Here Mi, M is same alkali metals, means you can see here NaI, here NaBr, then NaCl and then NaF. Here when you can see the NaBr, small cation, metal is same, cation is same. So, this property is not depend upon cation. This property only depends upon anion, because size of an ion is different. Here fluorine, chloride, bromide and iodide. Size of iodide is larger. So, my dear friends, your answer is C. You can go to the question number 22. Your answer is C. This is the correct order, because in Na, iodide is a large size of an ion. So, this ionic compound are more covalent in nature. These are the ionic compounds, but which ionic compound is more covalent in nature? Question is that. When metal is same, my dear friends, then you can see the size of an ion. When size of an ion is greater, then covalent nature is greater. Now, my dear friends, we can see the question number 23. Here question number 23. The alkali metals form salt-like hydrides by the direct synthesis at elevated temperature. The thermal stability of these hydrides decreases in which of the following orders? These are the hydrides and alkali metal hydride, and he wants the thermal stability. What is the concept? My dear friends, when you can see the MH, when you can see the MH, smaller in size and smaller in size, and this metal, when this bond is broken down, so metal is come in the cation form and this hydrogen is come in the hydride form. So, my dear friends, here you can see the greater the size of metal. This is the lithium, sodium, potassium, rubidium and cesium. Here you can see the greater the size of the metal. It means these metals, for example, cesium metal and hydrogen, here size is greater. So, it is easily broken down or it is break. So, it is form easily cation and hydride minus ions. Because, my dear friends, it is converted into cation form, it gives us hydride ion. So, it is act as a reducing agent, because it can itself oxidize. So, you can see the question number 23 here. When thermal stability, so you can see the small energy is required for breakdown of this cesium and hydrogen bond. So, my dear friends, small energy is required, means thermal stability is less. So, you can see here thermal stability is decreases because atomic size is increases. This is the concept. The atomic size is increases, so thermal stability is decreases. So, my dear friends, you go to the question number 23, B option, lithium, sodium, potassium, rubidium, cesium, and this question is also asked in 2008. Now, my dear friends, we can go to the question number 24th. Which compound will show the highest lattice energy? My dear friends, concept. Smaller the cation, plus smaller the anion gives high lattice energy. Here highest lattice energy is given by this NaF. Why? Because size of cation is smaller. Fluoride is same size. So, basic of size is depend upon this cation. So, my dear friends, answer is C, question number 24th. Now, we can see here question number 25th. Which of the alkali metal chloride forms its dihydrate salts easily? Here, my dear friends, you can go to the A option, LiCl, because lithium is abnormal behavior. It forms LiCl twice H2O. It is a hydrated and form this compound. Abnormal behavior of this lithium. Why this lithium has anomalous behavior? Due to three reasons. Number one, high electronegativity. Number two, absence of d orbital. Number three, high small size. Number third, small size. These three reasons are there, and due to three reasons we can see here lithium form the hydrated compound or hydrated salts. Now my dear students, we can go to the question number 26. Crude sodium chloride obtained by crystallization of brine solution does not contain. Concept. What is a brine solution? My dear students, 10% NaCl solution is called brine solution, and in this brine solution, my dear students, MgSO4 is not present because MgSO4 is insoluble in nature. So you can go to the A option. Now we can go to the question number 27. In Kastner-Kellner cells for production of sodium hydroxide, here this is sodium hydroxide. This production of sodium hydroxide in Kastner-Kellner cell, brine is electrolyzed using graphite electrodes. Which one of the following statement is correct? Here my dear students, you can see the sodium amalgam is formed at mercury cathode in Kastner-Kellner cell, because sodium is obtained and mercury reacts to form NaHg, and when it is heated you can easily get this sodium metal. So you can use this sodium amalgam is formed at mercury cathode. Mercury is used as a cathode. Now, my dear students, this question is also asked in NEET 2013. Here answer is C. Now we can go to the question number 28. Which of the following statement is incorrect? Here we can see that aluminium reacts with excess NaOH to give AlOH whole thrice. Sodium metal dissolved in liquid ammonia to give blue solution. It's a correct statement, because due to this ammoniated electrons. NaOH reacts with glass to give sodium silicate. Correct. Sodium bicarbonate on heating gives sodium carbonate. Yes, and carbon dioxide is evolved. But my dear students, this statement is incorrect. Why? Due to reaction. You can see the reaction. Aluminium reacts with NaOH in the excess of NaOH to form twice Na AlO2. First you form aluminum hydroxide and then twice NaLO2 plus hydrogen is liberated. So my dear students, this is called sodium meta-aluminate. This is called sodium meta-aluminate. So my dear students, you can see the reaction. In this section, aluminum reacts with excess sodium hydroxide to form sodium meta-aluminate, and this is the answer. Question number 28, you get the answer C. Now we can go to the question number 29. Here, in which of the following process fused sodium hydroxide is electrolyzed at 330 degrees temperature for the extraction of sodium? Sodium hydroxide is fused condition and electrolyzed at 330 degrees Celsius, and you get sodium. My dear students, what is this process in which sodium hydroxide is used and we get sodium as a product? Here you can see this is called Kastner process. This process is called Kastner process. In Kastner process, you can see the NaOH is converted into sodium metal. Now we can go to the question number 30. Which of the following is known as fusion mixture? My dear students, fusion mixture is a mixture of potassium carbonate and sodium carbonate. This mixture is always called fusion mixture. Question number 30. This question is also asked in NEET 1994. Now we can see here question number 31. The correct order of atomic radii in group 13 element is, my dear students, when you can go boron, aluminium, gallium, indium and thallium. It is a 13 group elements. You can write in this way Bal, Ganesh in Thailand. You can write here, remember here Bal, Ganesh in Thailand. And when you can move top to bottom in a group, here you can see that here boron, aluminium, indium and thallium. Boron, aluminium, indium and thallium. These are present. Boron, aluminium, indium, thallium means if you remove this gallium, then order is same, because in gallium it is the exception 8% before the boron, and atomic size of aluminum is greater than gallium. So, boron, aluminium, indium, thallium and exception is gallium. So, my dear students, you are answer question number 31, you can go to the D option. Now, we can see the question number 32. LF3 is soluble in HF only in presence of KF. It is due to the formation of, my dear students, when you can see the question here, ALF3 plus KF, both are reacts with each other to form K3 ALF6. This is formed. So, it is a electrolyte in nature, and due to the formation of this compound is a electrolytic. So, you can go to the question number 32, answer is your B, K3 ALF6. Now, my dear students, we can see here question number 33. Here the stability of +1 oxidation state among helium, aluminium, gallium, indium and thallium decreases in the sequence. This question is asked in 9 and 15. So, what is the concept? First of all, you can write the boron, aluminium, gallium, indium and thallium. This is 13 group. Here electronic configuration is NS2NP1. Now, we can see this is the heavy metal. In heavy metals, my dear students, this +1 oxidation state stability is maximum, increases due to inert pair effect. Due to inert pair effect, stability of +1 oxidation state increases. So, you can see here stability increases, +1 is more stable than +3. So, thallium is +1 oxidation state increases, you can go to the +1. So, you can see here this thallium, indium, gallium and aluminium go the A, because stability +1 increases due to inert pair effect. What is the inert pair effect, my dear friends? In heavy metals, these two electrons are inert in nature. So, these electrons are not go to the higher energy level. So, only one electrons and electrons take part in the valency. So, +1 oxidation state is stable and it is called inert pair, because it is not reactive. So, it is called inert pair. So, your answer is A. Question number 33.